Okay, next we have question number 7. Very important question. It has been asked in board exam couple of times for 4 marks. Now what you can see, we have fx is equal to mod x. 2 points are given, -3 and 3. So over here we will have 5 cases, right? So what we will have, first of all, we will say let C be a real number which is less than -3. So for all this, over here we can observe it as mod x. Since it is less than -3, I can write it as -x plus 3, right? So again we will say limit extending to C fx is equal to limit extending to C, it is -x plus 3, so it is -c plus 3. So f of C will also be -c plus 3, right? Both are equal, hence it is continuous. So this is case 1. What will be case 2? Case 2 will be C is between -3 and 3. Now it is less than case we have covered. Now C is between -3 and 3. Then what will be my function? Then for all the real numbers, my function will be -2x. Again, I write the same thing. That means limit x tending to C fx is equal to limit x tending to C -2x, that is -2c. Which f of C will also be -2c, hence it is equal, right? Then third case will be, I'll say let C is greater than 3. So again my function will be 6x plus 2, right? So 6x plus 2, again we'll have the same thing, limit x tending to C fx, limit x tending to C cx plus 2, which is 6c plus 2. So f of C will be 6c plus 2 and hence both are equal, so it is continuous. So these are the 3 cases which will always come out to be continuous, but since it is a 4-marker question, so we have to write and we have to present it in this manner. The next case will be, we will check for point -3 and 3. Okay, so when x is equal to -3, what we will have? We will have left hand limit, that is limit x tending to -3 of minus. So if it is -3 of minus, it means it is less than -3. So less than -3 means it is -x plus 3. If I put the value, what will I get? It will be 6. Similarly, if I say limit x tending to -3 plus, so it will be limit x tending to -3, plus means greater, so it is -2x. So again if I put -3, I will get 6. So f of -3, I will put in the in the function where I have equal to sign. So again it will come out to be 6. All the 3 are equal. It means the function is continuous at x is equal to -3. Then for 3, again we will do x tends to 3 minus. So 3 minus means it is less than 3. So it is -2x. So it will come out to be -6. Limit x tending to 3 plus, it means it is greater than 3 now. So we will say x tending to 3, that is 6x plus 2. So it will come out to be 20. Both the values are not equal. Hence the only point of discontinuity in this function is x is equal to 3 point. We can see x is equal to -3 is the point of continuity. So the only point of discontinuity is x is equal to 3. So for all the questions where you have 2 points, you will have 5 cases. In the same manner you will be doing. You will try question number 9, 10, 11, 12. Then question number 13 can also be done on the same lines. Question number 14 is also, 14, 15, 16 is also exactly on the same lines, right? Question number 20. Now again what we have a function x square minus sin x plus 5 and the point is given as x is equal to pi. We have to check the continuity at this particular point. So what I will do, I will just write limit x tending to pi fx. Since the function is not behaving differently at pi, so I will apply the first definition. So it is x square sin x plus 5. So it will come out as pi square. What is sin pi is 0 plus 5. So pi square minus pi square plus 5. Now what will be f of pi? F of pi will again come out to be pi square plus 5. And since both are equal, hence the given function is continuous at x is equal to pi. Okay, now what we will do is, this is question number 22, which says discuss the continuity of all the trigonometric functions, that is sin x, cosine x, cosecant x, tangent and cotangent. We have to check the continuity of all. So to check the continuity of all the functions, we will just check the continuity of sine and cos and then apply the algebra of continuous functions, and then we will prove the result further. So for continuity of trigonometric functions, what do? We'll say let C be any real number. Then what do we find? We find the left hand limit as well as the right hand limit. So we will say let h tends to 0, this will be f of c minus h. So what is f of c minus h over here? It will be sine of c minus h. Why we are doing this? To find the value minutely. Although we know sine x, the graph is this. So it is always a continuous function. But how do we write it mathematically? We'll write it like this. Now we'll apply the formula of sine a minus b. So it will be sine a cos b. The formula that we'll apply, sine a sine b minus cos a sine b. Right? Now if I put the limit over here, this is h0, so cos 0 is 1. So it will come out to be sine c, and over here cos c is here, sine 0 will be 0, so it will be 0. So what I'll get? I'll get sine c. Let's check for right hand limit. So similarly, limit h tending to 0, it will be f of c plus h. So limit h tending to 0, it will be sine c plus h. Now for sine c plus h, again I'll apply the formula. So it is limit h tending to 0, it will be sine a cos b plus cos a sine b. Right? Again I'll separate the limit. So over here it will be sine c plus 0. Now f of c will come out to be sine c. Since all the three are equal, we say sine is a continuous function throughout its domain. Right? The same step we can do for cos. Now what is the algebra of continuity? It says if two functions are continuous, their sum, their difference, their product and their quotient, provided it is defined, are continuous. Right? So based on this, similarly we will prove for cos x. Now based on this, we have question number 21, which says prove that sin x plus cos x is continuous. So we know sin x is continuous, cos x is continuous, so their sum is continuous. Similarly, the second part says sin x minus cos x is continuous. Again, based on the same thing, sin x is continuous, cos x is continuous, so their difference is continuous. Similarly, sin x into cos x will also be continuous. Over here for tan x, we will say tan x can be written as sin x upon cos. This is defined except when x is equal to what? Pi by 2. So, it is continuous throughout its domain except pi by 2 and minus pi by 2. For that matter, right? Similarly, for cot, secant and other things, we will say, so it will be written in terms of, like, if I say for sec, this, if I write it in as general term, I'll write for 2n plus 1 pi by 2. Except these points, it is continuous at all the points. Similarly, for sec x, we will say 1 upon cos x is continuous at all points except these points. Similarly, for cosec x, we will say it is continuous at all points except x is equal to n pi points, where n belongs to integers. Similarly, for cot, we will say it is defined for all points except as x is equal to 2n, except x is equal to n pi. Put like this, sin x and cos x are continuous throughout its domain. Tan x and sec x is continuous throughout its domain except the points at x is equal to 2n plus 1 pi by 2. Cosec x and cot x are continuous throughout the domain except at x is equal to n pi, where n again belongs to set of integers. Right? Next we have question number 23, which says you have a function sin x upon x and x plus 1. This is at x less than 0 and this is x greater than equal to 0. We have to find the points of discontinuity. So again we will have three cases. Case 1, we will say let c belongs to minus infinity to 0. For again we will have f x is equal to sin x upon x. So we will say limit x tending to c sin x upon x will be sin c upon c. So I'll write it like this, and f of c will also be sin c upon c, so hence it is continuous. Again for 2, we'll say let c belongs to 0 to infinity. Again the value of the function will be x plus 1, and the same result we will be writing for that. Now the crucial point, as I told you, is c is equal to 0. So the moment we have c is equal to 0, that is case 3, we will have left hand limit, which is limit x tending to 0 minus. If I say 0 minus, it means it is less than 0. So for less than 0, the value of the function is sin x upon x. And try to recall the result which says limit x tending to 0, sin x upon x is equal to 1, right? Then what will be the right hand limit? We will say limit x tending to 0 plus. So if it is 0 plus, fx is equal to limit x tending to 0, that is x plus 1. If I put x as 0, it will come out to be 1. Left hand limit is equal to right hand limit. The value of the function for equal to will be, if I put x as 0, it will come out to be 1. So all the 3 points are equal. It is continuous for less, it is continuous for greater, it is continuous for that point. So it means there is no point of discontinuity. Do try to read the statement of the question, and the final answer will be according to the statement of the question. If the question says find all points of discontinuity, and if you are not getting any point, you will say there is no point of discontinuity, right? And if the question says check whether it is discontinuous or check whether it is continuous, so accordingly we will answer, right? So question number 24. Next we will move on to question number 24. Next question 24, very important question, has been asked in board exams many times. So question says determine if f is continuous function. So now we don't have to see the point of discontinuity, but to see whether it is continuous, again we have to do the same thing. So both the questions are on the same line. So again we will have case, since x is not equal to 0, so I will have only 2 cases here. Case 1 will be, I will say let c be any real number which is not equal to 0. So for all those functions, for all those points, my function will be x square sine 1 upon x. So I will say limit x tending to c, x square sine 1 upon x. So it will be c square sine 1 upon c, right? And f of c will also come out to be c square sine 1 upon c. Both are equal, hence it is continuous. So the only crucial point always is the point at which the given value is equal. So we will say now let c is equal to 0. So I don't have left hand and right hand limit. So I will directly write the value limit x tending to 0 fx. Now over here, if I write limit x tending to 0, x square sine 1 upon x. Now how to solve this particular thing? Now what we will do is, I know sine 1 upon x, the value of sine always lies between minus 1 and 1, right? Then if I want to obtain this particular function, I will multiply it by x square on all the sides, right? So it will be like this. Now let's put the limit on all the points. So we'll have limit x tending to 0 minus x square, limit x tending to 0, x square sine 1 upon x, then limit x tending to 0, x square, right? Now the moment I put the limit, this will be 0, this will be x square sine 1 upon x, and this will be 0. So what does it mean? The value of the limit is also 0, right? So now the limit is 0. Now f of 0 is given to be 0 over here. So limit x tending to 0 fx is equal to f of 0, which is 0. It means the given function is continuous throughout its domain, and hence we don't have any point of continuity. The question was discuss if f defined by the continuous function. So we'll say hence it is a continuous function. If the given function is continuous throughout its domain, then the function becomes a continuous function. Exactly on the same lines, everyone can try question number 25, right? These are the important results that we will be using in continuity. So what are these results which we have done in 11? Just have a quick recap of all these results. Limit x tending to 0, sin x upon x is 1. Similarly, tan x upon x is 1. Limit x tending to 0, ex minus 1 upon x is 1. Limit x tending to 0, ax minus 1 upon x is log a. Limit x tending to 0, log 1 plus x upon x is 1. Similarly, limit extending to is xn minus an upon x minus a is na n minus 1. And these are the two new results. Limit extending to 0, sin inverse x upon x is 1, and similarly tan inverse x upon x is also 1. So these are the results which we will be using in the question. So we have to make a note of all these results, right? So now we have question number 26. Now these are the third type of problems. As we said, we have three types of problem in the continuity. So this is the third type of problem where what is given, fx is a function such that at x not equal to pi by 2 it is given like this, and at x is equal to pi by 2 it is given to be 3, and it is given that this function is continuous at x is equal to pi by 2. So it is given to us that the function is continuous. We don't have to prove. What we have to do, we have to find the value of this k over here. So first and foremost thing that we will be doing in all these type of questions, to remember that we will write, since f is continuous, so what happens? Left hand limit is equal to right hand limit is equal to value of the function. So this will be the first line that we will be writing. Since the function is not behaving differently, so I'll simply write the first definition. Limit extending to pi by 2, fx is equal to f of pi by 2. Why? Since f is continuous at x is equal to pi by 2, therefore what we have, limit extending to pi by 2, fx is equal to f of pi by 2. F of pi by 2 we know is 3, because the value of function at x is equal to pi by 2 is 3, right? So now let's put the value. So we will have limit extending to pi by 2. This is k cos x pi minus 2x is equal to 3, right? Now do remember in class 11 we said whenever limit is tending to pi by 2 pi, what we take? We take the denominator as t or h, anything. So I will take pi minus 2x as t. So what does it mean? Now I will write x in terms of pi by 2. Over here if I put x as pi by 2, then what will t come out to be? T will be 0, because if I put it over here pi by 2, pi minus pi will give me 0. So I know my limit has changed to 0. Now let's see what is the value of x from here. So from here I can write it as pi minus t upon 2 is equal to x, right? So this can be written as pi by 2 minus t by 2, and over here this is t. Now what do we know? Cos 90 minus theta is, everything is equal to 3. So what do we know? Cos 90 minus theta is sin theta. So sin t by 2 upon t is equal to 3. So over here to make this one I need to multiply and divide by 2. So this is 1. What will I get if I put the limit? K by 2 is equal to 3. Hence k is equal to 6. So this is the value of 4 marker question. Very important. This is how you have to present. Number 27, what do we have? It says fx is equal to kx square when x is less than equal to 2 and 3 when x is greater than 2. Again it is given to be continuous at 2. Just see at the point at which the function is behaving differently, there it is given to be continuous for both the functions, over here at pi and over here at 2. So again we will say since f is continuous at x is equal to 2, therefore left hand limit over here is equal to right hand limit is equal to the value of the function at 2. So if I see the left hand limit, what will I get? If I see the left hand limit less than, it is kx square. Then over here extending to 2 plus, it will be 3, and this will also be, if I put equal to sign is here, if I put x as 2, so it will be 4k. So from here also I will get 4k is equal to 3 is equal to 4k. So what will be k? K will be equal to 3 by 4, right? So this is how we have to present a question. The only difference will be sometimes you may get an easy question to solve for the limit, or all the questions that we have done in class 11 can come over here for continuity, right? Similarly, we have this question. We will say f is continuous at x is equal to pi. Therefore, limit x tending to pi minus fx is equal to limit x tending to pi plus fx is equal to f of pi, right? So this is limit x tending to pi. If it is less, we can write kx plus 1. Similarly, x tending to pi cos pi, and this is equal to, if I put pi over here, it will be pi k plus 1, right? So pi k plus 1 is equal to cos pi is minus 1. So this will be, k will be minus 2 upon pi. right? So this is how we will be solving these type of questions. On the same lines, you can do question number 29. 30, if you remember, this type of question we did in class 11th also. So what we have now, the function is given to be continuous. We have to find the value of a and b. Since the function is continuous, so it will be continuous at two crucial points, that is 2 and 10. So we will write, since f is continuous at x is equal to 2. So what does it mean? Left hand limit at 2 will be equal to the right hand limit at 2 will be equal to the value of the function, right? So left hand limit means what? It is 5 over here. Right hand limit over here, what does it mean? It will be a x plus b, and equal to means 5 again. So what will I get? 5 is equal to 2a plus b, right? So let's mark it as equation 1. Then similarly we will say, since f is continuous at x is equal to 10, therefore left hand limit for 10 is equal to right hand limit is equal to the value of function at 10, right? So left hand limit is what? Left hand limit will be less than, it means ax plus b. This is right hand limit, it means 21, and equal to is also 21. So we can say it as 10a plus b is equal to 21. So let's say this is equation 2. So now when we have equation 1 and 2, we can solve it linear equation in 2 variable. So what I will do, I'll just write it over here. So this is 5 is equal to 2a plus b. So 10a plus b is equal to 21. So subtracting, what will I get? This is minus 8a. So this will be minus 16. So a is equal to 2. A is equal to 2. If I put the value of a2 in equation 1, what will I get? 2 into 2 is 4. So b is 5 minus 4, that is 1.